This is our metadata watermarking project. The objective of our project is to develop advanced watermarking technology specifically designed for video streams. One of the key objectives is to guarantee that the watermarks remain imperceptible to viewers. Another one is the inclusion of watermarks does not slow down the delivery of the video content. What we did so far is that we completed a script that can embed metadata watermarking within video content for Dash. We completed a script that can validate the presence of metadata within the video content for Dash. We set up a mock live stream to exhibit how our system works. We established an EC2 instance that can perform our metadata watermarking solution within the cloud. We utilized Jenkins pipelines to set up a front end to interface with our system. Me and James are working on HLS inclusion. HLS is basically a tool used to deliver media content over the internet by segmenting the content into smaller files and then deliver to the viewer's devices. How this code works is that it creates a manifest which contains all the media content's data, and it acts as a roadmap for video players. The manifest includes 3 different types of playlists: the master playlist, the variant playlist, and the media playlist. The master playlist provides an overview of available video qualities and references the variant playlist. The variant playlist represents different video qualities, while the media playlist contains the actual video segments. The importance of multiple video quality is that it offers an adaptive streaming where the player dynamically adjusts the video quality based on network conditions. It's to cater to diverse viewer needs and device capabilities.
Streams, I'll be going over both the HLS portion and the remaining challenges. Here you can see the code for embedding a UUID into the header of an HLS manifest. And next you can see we have code for correctly setting the path from the manifest to the stream playlist, and from the stream playlist to the designated data segments. And here you can see that Charles and I were working on validating the presence of a UUID, and we start by reading the manifest labeled output.m3u8 and then find where the line begins that says hashtag ext-x-define, which is a line that contains the UUID that we embedded within the manifest. And then it prints that line to the terminal so that we can read it. So some of the remaining challenges we have to work on is implementing a Mongo database, making the Dash script more generic, revising the HLS script, and making the HLS script modular, as well as completing the documentation.
Okay, so this is the coding portion of the project, and because of the time constraint, I'm just simply going to be giving a general overview of each file and its main functionality. If the professor or the TAs have any questions, feel free to reach out to me via Canvas or email, whatever your preference for communication is. So here we have our first file here, which is main.py, and basically this is the main file that calls all the other helper files. And we're trying to be modular here, and because of the modularity of it, we want to abstract the logic and complexity to the other files. And so here we have a few arguments, so -o and -u. -o is the output folder that we create with the manifest inside of it, and then here we have the manifest URL. And so this manifest URL is exactly what it says. It's the URL to the exact manifest that we're trying to grab the content from. And so basically, like I said, this main here just, first of all, it instantiates a dictionary value that we then populate with the content from the parsed manifest. But then it also, of course, calls all of the other helper files here, which do all of the logic. So I'll just give a quick scroll here. Okay, cool. Okay, so here we have media transfer, and this file here is responsible for transferring the files to and from the cloud, specifically the CDN in the S3 bucket, as well as any URL link that we get. We're basically extracting the content into a folder from the internet, and then we also check the status codes to make sure everything's okay. Um, and then here, of course, is where we're inserting into a S3. Okay, so this is the extract media. This is the actual meat and potatoes, per se, of our application here, of our script. So this is what actually takes the manifest content that we parse and stores it into the dictionary value that you saw earlier in main. And so this is what actually grabs all the content from it and stores it there. So I'll go slow here, just slowly scroll. And so here we have some helper functions for handling different formats. So here we have the compact format and non-compact. Here's another helper function here to get the quality IDs. And then here we apply a UUID to a init, it's called. It's a type of fragment. And then here we have locate line. And this locates the specific line within a manifest. Extract media is what extracts the media content, specifically the fragments and the init, which are the types of stored content that we need to be able to play back the video. And so this is what this function does. So it extracts all of the init and the fragments and whatnot. So here we have the error handling, and this is just for formatting errors specifically, so they're real nice in the terminal. And the validate media, this can be run independently from main.py, but it can also be run with it, in the sense that main.py imports validate media and uses some of the functionality here to validate internally before we validate from the CDN that we use. So here, validate UUIDs where we validate, and extract UUIDs where we extract the UUID. And so this, like I said, can be run independently of the main.py, and it's similar in the sense that it has its own arguments here that you can pass in. And usually when we do this, it's to validate from a external CDN, say from the, because we use a CDN to store the contents of our S3 bucket. So when we validate from the CDN that we store from the, when we validate the contents of the CDN, which would be the contents of the S3 bucket, we do this specifically by running validate media, where we grab the init, and because that's where we apply the UUID and validate from there. Right. Sorry if this is all confusing jargon, but a bit of a time constraint here. So database.py, basically we're using a mock database, which is a db.json here. And so we store all the corresponding UUIDs inside of this .json file here. And this db.json is just, you can insert and extract, and it opens and writes to it. But we're going to replace this soon with Mongo, so it'll be an actual database.
Hello, my name is Manuel Castro, and I'll be trying to do this demo as fast as possible, so we don't have enough time. Okay, so to be able to create this project, we were to be able to use AWS Cloud, and then you create EC2 interface for computational uses. Also, we had to use S3 for S3 buckets to storage data, and also be using another service like the CloudFront to do a CDN for our bucket and also to all our media. Also, we create several signals like the live flows to be able to stream in live with several formats like HLS, CMAF, and Dash. And also we create ingestion of files for VOD that are going to be video on demand for the same for HLS and the Dash protocol. Dash mean is stand for dynamic adaptive streaming over HTTP, and HLS is going to be a HTTP live streaming. Okay, now let's go to the AWS so we see the several things that we have here in our interface. First, here we have the EC2 interface we are right now using. Here we can see that we have all the workflow that we are using to create the live streaming service, a media live channel, to create a live streaming service using the most three common protocols that are going to be HLS, CMAF, and Dash. And we have all of this working here. And also we have here some assets that we can see here that we are using and ingesting those assets to create a VOD, video on demand files over the CDN. We're going to use first, we're going to use one of these link, right? We're going to be opening, and then to be working of the To be working of the UI part, we were using Jenkins, and then with using on the Jenkins, the user gonna be able to connect to our application, and then Jenkins will provide the access to the bucket, to the database, to the EC2, to the IAM role services. So in that case, the user can have all the security protocols and all the keys to be able to interact with the several resources that we have on AWS, and also the AWS CLI. They're gonna be the way they're gonna be communicating and doing actions one process with the other one, right? And also GitHub, because our code is gonna be getting from GitHub, it's gonna be deploy the code inside our EC2. It's gonna be able to run using Jenkins as a workflow with pipelines. Okay. Now let me show you that part. Let me go there. Here we have we have the CDN, the CloudFront, and we have several CDN that we are using right now for our application. And now let me log in here in AWS in the Jenkins with our password. Okay, so right now we create to be able to not to need to go and do a login inside the AWS and had to do the work inside the EC2 machine. What was created here was a way that we're gonna use the Jenkins pipeline to communicate and make action like a workflow inside the AWS services. So we have several like here. We have the way to start machine, also to stop the machine. In that case, we can save money because all those machines that we have deployed on the AWS is costing money for us. And we also have the way that we can run our scripts and get the things. So the first thing we're gonna do is we're gonna go here. We're gonna go there one VOD video that we are ingesting, right? And then let's preview this video. It's gonna be a very fast video. It's gonna be a 30-second video. As you can see here, the video is ingesting, and we're gonna try to simulate the real user case that's gonna be where we're gonna have a signal for Warner Bros. And then that signal we're gonna apply a CPRT with UID inside, and then that signal we're gonna be still by the hack, and I'm gonna be putting inside an S3 bucket, and then using a CDN is gonna be delivered, and then we're going to try to identify a signal as our. The first thing we're going to do is we're going to get here the URL, right? And then we're going to come to our Jenkins, and then we're going to run the main script. That's going to be the first step. And then in the main script, we're going to put here, we're going to select what's going to be our output directory. It's going to be the directory. We're going to save all the information of what we're doing, right? And then we're going to put our link here. I'm going to paste the link. And then here, this is going to connect using SSH with our EC2, and then you're gonna start running all the code inside, also setting out all the environment inside the EC2 machine. And then you can see this is happening here in real time, so we can have access to all the logs and all the process that is being printed to the console in this case. This video is gonna be like how to very fast. So what happened here is gonna be the following. We're gonna be getting the manifest, and then we're gonna try to parse the manifest. After that, we're gonna start to extracting all the video segments and the audio segment, and we will apply to every init MP4 for the video from the audio. We will apply the CPRT box with a one UID that's gonna be unique, that's gonna be inserted here, as you can see here. And then here we're gonna at the end, we're gonna be able to, now it's finished, I can show you here the pipeline. So at the end here, we're gonna be showing how was the total time that takes to apply our UID, and then after we apply the UID inside the CPRT board, inside the NEMP4, we're gonna validate that the information is there to be sure, right? And then the next step is gonna be to clear to deleting whatever resources we are using, whatever temporary folder, whatever thing we are using. We're gonna see. Now we're gonna do the second step that's gonna be the validation. What's gonna be happening here? We're gonna try to validate because we are putting this one in S3 bucket, and after that we are streaming that while using a CDN, right? We're gonna try to validate that we are able to find over any URL our CPRT with the UID inside. So, and then what we're gonna do here, in this case, we're gonna do the two cases. The case that we have a signal that have the CPRT, and the case that we have a signal that doesn't have the CPRT. So in this case, we're gonna use none. I mean, we're gonna use the URL of the last signal we process, right? And then when I go run here, this is gonna go again to the EC2 machine, it's gonna connect to the EC2 machine, and then it's gonna try to validate if the file inside the CBRT box also. And if we come here, we can see the output, and then we can see that we connect. We don't load the INI-MP4. That is the only file that we need to do this one, right? And then with that MP file, we validate that successfully that belong to us, and this is the time it takes in milliseconds to do this process. You see, it's very, very, very fast. And now we're gonna try. We're gonna get, for example, gonna go to BitMobbing, and let me go, for example, a test. In this case, well, let's get a test signal for BitMobbing. This is another video that doesn't belong to us. We're gonna copy the URL, and then we're gonna try to validate this URL with our code. And then what's gonna happen is supposed to not be able to validate the code because this signal doesn't belong to us. So yeah, we come here and we check the output or our thing. We see that in this case here, okay, we come here and we can see that the no UID has been found. That means we don't have a CPRT inside that signal that belongs to us. Okay, I think that is all for our presentation.